Alright, today this video is going to be about sets. Okay, so this is what we're doing in class for the second lesson. Okay, and hopefully explaining sets to you guys. I'm going to explain this through the use of an example. So if you look at this set that I've drawn up on the right hand side here, okay, it might look kind of messy at first. Yeah, sorry for my bad handwriting. But if we take this down and kind of break it up into bits, what we can see is that we've got a Venn diagram, and in this Venn diagram we've got something that's labeled A, okay, and this circle extends all the way around. You can see here, so it pretty much overlaps something that's on B. So I'm just going to redraw that. So this set here, that set is set A, okay, and part of set A actually includes set B as well, so you can see that I won't draw the whole thing. Okay, but you can see that there is some sort of overlap. Anyway, so now let's look at some other things, some aspects of this Venn diagram. You can see there's a set C here. It doesn't overlap with A or B. And there's also some numbers here, 1, 8, and 9, which are not part of set A, set B, or set C. Okay, so we'll investigate that a bit further throughout this video. Alright, so there's just going to be a few definitions I'm going to put up here. So the first one is U. What does that U mean? Okay, so if you see here, I've written this U. Sometimes you might see it as a different symbol. You might see it as something looks like that, or something as like, as an epsilon sometimes. These all essentially mean the same thing, and this just means the universal set. Okay, and what we mean by the universal set is everything. Okay, so let's have a look at what the universal set is. So let's just write down in proper notation. So the universal set is equal to curly brackets. Well, you can notice that I've intentionally made this diagram so that the numbers go from 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 10. So the universal set is everything in this Venn diagram. So that everything in this Venn diagram starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that's the first bit, universal set. Alright, this next bit of information that we need to know is this symbol right here. Okay, this symbol right here means the null set. Okay, and null means 0. Okay, some of you might think, if I ask you what is the null set in this case, some of you may be inclined to say A. Okay, but it's actually not. When it says null set, it's referring to the number of numbers or the number of elements inside the set. So if we look at set C, you can see that set C doesn't have anything inside of it, so it has 0 elements. So we call this the null set. So in this case, the null set is C. Okay, so null set. Next one, we should probably define what these are. So it's probably good habit, okay, when you're starting off with these questions. A is equal to set A, B is equal to set B, and C is equal to set C. Okay, this might seem a bit tedious, especially since it's labeled A, B, and C already, but you'll see probably in the next video that when we start putting other labels onto here, that it is quite useful to have A, B, and C as almost variables that we use. Okay, so that's just something to consider for the next video. Now, if I said to you, A bar, okay, so you might not have seen this notation before. We call this A bar, there's a bar on top. That's also the same as saying A complement, okay, the complement of A. So that symbol means complement. In this case, when we're referring to the complement of something, we're referring to everything that is not in set A. Okay, so let me just change color here. Okay, let's have a look at what the complement of set A would be. So I'm going to label the complement of set A as this green color. So you can see that set A is right here, okay, all the way around. So when we're concerned about the complement of set A, we're concerned about everything that's outside of set A. Okay, so that means including this. Okay, but be sure that you don't consider this part. Okay, so you don't shade in this part. The reason being is that this is actually still, so this part here is actually still part of set A. So that's still part of set A, and we're concerned about everything that's not in set A. Okay, so what would your answer for this one be? I'm just going to change color back to black. Okay, so what's the complement of set A? Well, what's everything outside of set A? There's 1, there's 8, there's 9, there's 4, and 6. So let's write them down. So the complement of set A is 1, 4, 6, 8, and 9. Okay. And if I asked you as well, what is, for example, let's try B bar or B complement. Okay, I'll label this as maybe a different color. Let's make it purple. So everything outside of set B. So everything outside of set B will be this part. Okay, so not including this part. Okay, and once again, make sure you don't include the intersection, because the intersection is still part of set B. Okay, so in this case, what is everything outside of set B? Okay, so it's going to be 0, 1, 2, 3, 8, 9, and 10. Okay, so the set B, curly brackets, 0, 1, 2, 3, 8, 9, and 10. Okay, now there's two more things that we need to, I'm just going to draw a line here, two more things that we kind of need to look at. I'm just going to rub this out. So, two bits of notation that we need to look at now is A intersection B. Okay, and this bit of notation, A intersection B. So this is like an upside down U. That shouldn't have like a little tail. Let me draw it a little bit better. So it's an upside down U. Okay, this means intersection. Where does set A intersect with set B? That's how you should interpret this. So I'll probably draw an arrow here. This means intersection. So intersection, where does A intersect with set B? Well, I'm going to use a different color now. Sorry if this looks like a rainbow sort of example, but alright, so A intersection B. So if we look at the color yellow, I'm going to use the color yellow here, you can see this is where A intersects with B. So we're going to call this the intersection, and the set will equal, okay, what's inside this set? 5 and 7. Okay, so 5 and 7 are inside the intersection. If I asked you what the intersection of A and C were, okay, there is no intersection between A and C. Okay, so if I asked you A intersection C, there is no intersection between them. So in this case, what we would say, there is no intersection. You don't say 0, you say it is the null set. Okay, because if you say 0, it sometimes when you get the actual number 0, it might be misinterpreted as the number 0. So make sure you put down it's a null set. Okay, there's no such thing. Now, last bit of information we need to know is A union B. Okay, I like to think of this as the easiest one. Union is pretty much just all elements, where's my cursor? All elements inside A combined with all elements inside B. So you can see here, all elements A, all elements B, including the intersection because that's part of it. So this set will be, in fact, 0, 1, 2, sorry, not 1. 1's not inside that set. 0, 2, 3, 4, 6, 7, and 10. Okay. Now, that should pretty much be it for this topic. So I'm going to put up another example which has worded problems, and hopefully this overview, so pretty much just these bits here, hopefully they're oh dear, hopefully they're useful.